Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Now we are going to see one more problem on a line inclined to both the planes. Here, the front view of the line is given 50 degrees angle and also measuring 55 degrees angle. So angle and front view lengths are given. And the top view is 60 degrees inclined to XY line. So top view inclination is given, that is beta is given, but length is not given. Its end A position is given, and we are asked to find the true length and inclinations. Okay, so final projections are given, and from this we have to find the true length. Let us see how to represent. So the point A is 10 mm above HP. Draw a line here at 10 mm and mark a point here on the point line. So this is A dash front view and 15 mm in front of VP. So draw another line here in front of VP at a distance of 15 mm and draw a projector here onto the, if you draw a projector from A dash, we get a here on this 15 degree, this line. So one end of the line is given, is marked. Now let's mark the front view at 50 degrees angle. At 50 degrees angle, we draw a line which is of 55 mm long. The length of this line is 55 mm. So this point is B dash. This is 55 mm long. So A dash B dash is the front view and its length is given and it's marked. Now what else? Top view is 60 degrees inclined to XY line. Top view means AB. AB is at a 60 degrees angle. So at 60 degrees angle, we draw a line and point B is lying on this line somewhere, we don't know. Okay, so to get this, we know that B and B dash lie on the same projector. So from B dash, if you draw a projector and this intersection point is nothing but B. So we know that the point B is lying on this line as well as on this projector. So the intersection point is B, highlight AB. So what do you get? We get the finally AB, the final front view, top view of the line, and A dash B dash, the final front view. The final projections of the line are given, and this angle is alpha, this is beta. And we are asked to get the true length and the true inclinations with the HP and VP. Let's see how to get it. This is the draw a line here passing through B. This is the locus of B in the top view. And passing through this B dash, you draw another line. This is the locus of B in the front view. Now, with the A dash B dash as radius, A dash as center, rotate this point B downwards, and this point B moves downwards and moves as if it is an arc of a circle until this is parallel to the horizontal plane. So from this point, draw a projector onto the top view here, onto the locus, and we get the point B2 here. This is B2 dash actually. So here we get B2 here, and what happens? This is the line which is parallel to HP. When the line is parallel to HP, in the top view, we see the true length of the line. So AB2 is the true length of the line, and that's marked. You can measure the length of this line AB2, that is the true length. And also, if you measure this angle, this is angle phi, angle with the vertical plane. So we are able to get angle phi and also the true length of the line. Once you know the true length of the line, take the true length as radius, and from A dash, you draw an arc and cutting this locus here at a point. This point is nothing but B1 dash. The meaning of it is the line is assumed to be parallel to VP. When it is parallel to VP in the front view, we see the true length of the line. So join A dash, B1 dash. This is the true length. Of course, by taking the true length, we mark it. Now, this angle is the angle with the HP, that is theta. So we are able to find the true length of the line and true inclinations of the line with the HP and VP. Like this, we get the required data and final projections. Okay. So in the next video, we are going to see one more problem. Like, share and subscribe. Thank you.